Hi there, I hope all of you guys doing well. Me again to introduce for you about object-based modeling and simulation of CO2 migration in saline formation of Nam Van field in Cửu Long Basin offshore Vietnam. This presentation I was distributed since 4 years ago, but I found an interesting idea to deliver in this channel. So let we go one by one these presentations for exploration about CO2 migration in saline formation. So far, this presentation I will introduce for you in 6 main division. First, I will briefly with introduction, and then we go with the methodology, and next we continue with the geologic model. After we confine the geological model, we go with the simulation model. And next we go with the result and discussion. And finally, we wrap up some key message to deliver on this presentation. Okay, I go with introduction. I would like to introduce the research area. This is the research area we highlight in the red color, and it's mainly a site or located in the Cửu Long Basin. As far as we know, Cửu Long Basin is one of the biggest sedimentary basins, and that can be the potential for CO2 storage when the CO2 emission is the global and hot issue in the world. So far now, we go with object-based modeling. So why we need this method? This method can help us to capture the facies, architecture, and geometry. And also, we can consider general and isolated objects fully integrated. So you can see in this figure, normally we use the bit cell-based method to distribute the facies, right? But in the general reservoir, you can consider the object-based method to assign the general distribution inside the reservoir. And by this method, the real system will be representative in the reasonable way for you in 3D dimension, okay? So therefore, this is the reason I apply object-based method for this study. So the bit cell method is not suitable for this study, okay? And the next session we go with the methodology. Firstly, I need to collect the data such as the seismic interpretation. We need to know about the regional geology, the well log, correlation to get the top and sequence in each formation. And of course, the geophysical interpretation is very important to upscale the porosity, permeability from well log into the 3D dimension. After you collect the data, you need to consider to distribute the data in the facies or lithology model. Besides the lithology model, you need to consider or condition facies model in porosity and permeability model. We call it the modeling step. After the modeling step, we go with the transfer the static model to dynamic model by simulation. And in this step, we try to perform the CO2 injection inside the storage reservoir. Okay, that is the simple methodology I implement in this presentation. For the geologic model, we have the seismic interpretation like the top of the surface or the base and top of the horizon for your storage reservoir. And in this slide, I introduce for you about the illustration of the top and base of the formation. You see, this is top of the formation and this is the base of the formation. And we will try to distribute all of the information such as facies, porosity, and permeability inside in the two horizontal, okay? Before I go with the geological model, I would like to introduce some well data. For well data, I only have 3 wells because it is the initial stage of the field iteration, so I don't have so much data to construct the model. In this data, we have the well of porosity, the well of permeability, and finally, the lithology will be held included in the 3 wells. And I think with simple 3 wells, we can utilize the object-based method to consider for phasing modeling. This slide I will introduce for you about the geologic model-facing. After you have the well of facing, you can scale facing, okay? And then you apply the object-based methods. By the 2 steps, you have the model like this. And in this demonstration of the photo, you can see that the channel already represent, the Fluvial channel already represent in your model. And I decide to make the injector in the middle of the reservoir, and the injector will be located in the Fluvial channel. And we expected that the CO2 will move follow the Fluvial channel sand. Because the Fluvial channel have the high permeability, the high porosity rather than the shale formation. Okay, after you consider the phasing model are successful to construct the phasing, you need to consider or include your phasing inside the porosity. You can see that the porosity also show the Fluvial channel shape for your model. Similarly, you can consider the permeability. You can see that the photo already decide or assign the information of the Fluvial channel in the permeability. So, by consider together the model, you will implement the CO2 injection for this subsurface toroidal. And let's see how CO2 will movement inside this reservoir. For the simulation model, I try to inject in 5-year injection with the 0.1 million ton of CO2 per year. For the simulation scale, I would like to emphasize about the object-based method. Therefore, the simulation parameter of object-based method will be considered for the sensitivity analysis, such as the sinuosity of the channel, the length of the channel, and the anisotropy. This is the ratio between the vertical permeability and horizontal permeability. So, by the parameter, we expected that the CO2 movement will be trained or make the decision for your model. Okay, so the first scenario we consider the Sinuosity chain. Okay, in the left side you can see the bottom home reservoir performance for 4 case scenario, and in the right side you can see the CO2 evaluation movement from the bottom to the surface of the reservoir. And you can see that by changing this parameter, the CO2 movement just slightly change a little from the KD to KA. Okay, so I can say that it's not so different when we change this parameter, and it not affected so much to the CO2 migration. Okay, but when we have a look at the length of the channel, as I mentioned before, the channel will help decide the CO2 movement. Therefore, when we change the shape of the channel, the CO2 movement already change very different between the base case and the changing scenario. And we can confirm that based on this simulation, the length of the channel will be affected so much to the CO2 plume or CO2 migration in the saline formation, especially in the Fluvial channel formation. And now we continue with the final scenario, the anisotropy ratio. Once again, when we compare between the 0.1 to 0.5, the evaluation of CO2 from the bottom to the surface not change so much. And we can confirm that even though the bottom reservoir they didn't change so much, therefore this parameter is not important for CO2 migration in the level channel parameter. To wrap up with the conclusion, I would like to deliver some key message for this presentation. Firstly, the object-based method is suitable to represent the conceptual model, especially inside the level channel reservoir. The geometry of the channel is the most important parameter in the level deposit when we consider the CO2 injection, especially CO2 storage inside the saline formation. And the next bottom reservoir is also influenced by the channel length and sinuosity parameter. For the anisotropy, it is just like change the bottom reservoir inside the level channel formation. That is all about the conclusion and the key message I deliver for this interesting topic. Okay, and that's all about my presentation to consider object-based modeling and CO2 migration inside saline formation. Thank you for your kind attention.